Hi everyone, this is experimental B for the density lab, and what we'll be doing is determining the density of an unknown solution. So your next setup is going to require you to use a burette, which we've gone over in the techniques video, and a top loading balance. So the first step for this is we're going to have our burette here. We're going to want to rinse it through with water, like I've talked about in our techniques video using burettes. So I'm going to rinse this through with water twice, and then I'm going to prime it with my unknown. So while this is going on, I'm going to take a clean 150 milliliter beaker, and I'm going to pre-mass it. So if I put it on top of here, I will read that my beaker is 85.89 grams. So when you're doing this information, we're going to be using this chart here to organize our information. Your unknown, when you get that code, you're going to be putting in the letter there. So mine is unknown A, and you'll be getting it in 125 milliliter Erlenmeyer flasks. Okay, so I'm going to, while priming my burette with water and then my unknown, I'm going to keep going through with this. So the mass of my beaker is 85.88 grams here. Now the mass of the beaker is constant, and that's going to be the same for all these. That's not going to change. And that is going to be very reliable when we're looking into the density, because we're going to have to subtract that weight constantly throughout this experiment to account for the mass of the liquid that we're going through. So as you can see, my water is going through, and I'm going to begin priming with my unknown. So to do that, I'll just do 2 quick rinses of that. All right, so now that my burette is ready, I'm going to start with the experimental portion. So I've already worked through steps 1 and 2, and now I'm going to be moving on to 3. And what that asks you to do is to deliver a volume between 5 and 10 milliliters of your unknown. So I'm going to pick in between that. I'm going to say let's do 7. So from my burette, and you can see I'm starting at 0, I've prepped and primed the entire thing with my meniscus reading for 0. And that's going to help while I'm doing this, because my reading on the burette, in the end, the final reading is going to be what has been dispensed totally. So that's going to be nice when we're organizing our information. So here I go. I'm going to do about 7 mils, and I'm going to stop, let's say, in between 7 and 8, just for a good measure. Boom. So I stopped there, and if you read, and I'll let you guys take a look first, and I'll take a look. So my reading here would be 7, and each graduation mark is it's a 1/10 of a milliliter. So it'd be 7, there's 1 graduation, 2 it reaches. It's almost at the 3rd graduation mark, so I would say it's between 7.2 and 7.3. Let's say 7.25. We'll guesstimate in the middle. And remember that while you're doing this, you're going to want to read to 2 decimal places for the burette. So if I'm going to write this here, so my initial volume is 0, my 2 decimals there, and the final we said was 7.25. Moving on, we're now going to take this and weigh it. So this is my sample 1, and this will be the mass of the liquid and my beaker combined. So we have a mass of 94.49 grams. The mass of the liquid dispensed is going to be the difference of the beaker and the total. So 94.49 minus 85.88 is going to give me 8.61 grams. The total mass is 8.61 grams because we haven't added anything else. As we add The difference from your next sample will get added to our total mass. So that'll be the accumulating mass. And that's going to be really important when we're solving for our total density. So now here I noticed that, so this should actually say volume instead of mass. I noticed there is a little mix-up. And I will edit that so that will be correct. So moving on here, I would do the volume, same thing. The volume dispensed, 7.25 milliliters. And the total volume is 7.25 milliliters. Same thing here, we'll be adding the additions as we go. And this will just be the reading of our burette. So if I'm moving on to the next one, I'll go, and then step 5. So what this says is you don't dump this solution out, and we're going to keep adding between 5 and 10 mils each time. So again, I'll shoot for about 7. So let's say 14. So we're going to take those readings, and then I'll show you how to crunch those numbers. All right, so the volume that I read on here was 14.40. So when I'm filling out my chart, we're going to look here, right? So the initial burette volume is going to be the final from before. So it's 7.25 milliliters. Right? My final reading is now 14.40 milliliters. That was the reading that I just read from the last run. Here, the volume of liquid dispensed is going to be the difference. So I have 14.40 minus 7.25 should be around 7 because that's what I'm going for, and look at that. 7.15 milliliters. The total volume of liquid dispensed is always going to be your final volume when we're starting at 0. So I have 14.40 milliliters. So you can start to see this pattern going on, and this is helping you organize while going across this information. You're going to take your beaker now, and we're going to weigh it again. We should expect the mass and the mass of the beaker and liquid to keep increasing. So it should definitely be above 94.49. Lo and behold, we have that. So I'm going to record that 102.86. And you'll notice I'm trying to keep this very neat. It's really important to keep your data neat and organized when you're collecting this data, because being sloppy when recording can skew your results. Now that I have this, I can calculate the mass of the liquid dispensed by subtracting again, just like we did before. And each time it should be around the same thing, or rather, we should see it going up because we're adding more liquid to it. So the mass of my liquid dispensed, this is, hold on here. So the mass of my liquid dispensed is going to be the difference between these two, right? Our total is 16.98 because that's subtracting from here, right? The mass of the liquid dispensed in that instance is going to be 102.86 minus the previous total mass, 94.49. 102.86 minus 94.49, and I'll get that 8.37 grams. So you can see, as long as we're shooting for around the same amount, we'll keep getting that same mass and that same volume. We're going to keep doing this for 2 more trials until we get 4 sets of data with total mass of our liquid dispensed and the total volume of our liquid dispensed. From that, we'll calculate average density and then analyze it graphically to see which can work better to predict your average density.